Greetings, folks. I hope that you are all doing quite swelly on this rather spectacular evening. Welcome to the 5th episode of the Alex Toast Medical Marijuana Logs. Today we're going to go over some issues about CB1 receptors, CB2 receptors, and receptor agonists and antagonists. And we're going to talk a little bit about anandamide versus THC and just kind of a little bit more in depth on the chemical biology of all this. So I got a cool little whiteboard for the assistance of the explanations of these things, and it's kind of a lot of information to kind of take in all at once. So I figure it's a little bit easier if you guys actually look at it for a little bit. So let's see if we can get this here in the shot. Alright, so we got CB1 receptors. Now, basically I'm going over this because in your body, in the endocannabinoid system, your body picks up the different cannabinoids that exist through at least 2 different currently discovered cannabinoid receptors, and those 2 different receptors are CB1 receptors and CB2 receptors. So, if you look here, we have the CB1 receptors, and the CB1 receptors are located in the basal ganglia, the limbic system, hippocampus, cerebellum, and reproductive systems. It is not, however, they are not found in the medulla oblongata, and the medulla oblongata is responsible for respiratory or cardiovascular functions. So basically, because there are no CB1 receptors in the medulla oblongata, that means that if you take in too many chemicals that could be picked up by these CB1 receptors, you don't stand at risk for respiratory or cardiovascular symptoms or ailments that might come up because of that, which is different, I might point out, than the opioid system in your body. Next little bullet here. It's responsible for the euphoric and anticonvulsive effects of cannabis, the CB1 receptors are. So the chemicals that the CB1 receptors pick up will help you feel the euphoria and basically like MS patients and different people who have different muscle spasticity issues. The CB1 receptors are what's really going to help them. Now you look here, I wrote THC, wrong way. We have THC and we have CBD that work really well with these CB1 receptors, and these are just a couple of the many that work with these receptors. But just for kind of quick example here. Then, a little bit further at the fancy board, we have the CB2 receptors, and the CB2 receptors are found largely in the immune system, the spleen, and the peripheral nervous system, and the cerebellum. And CB2 receptors are largely responsible for the anti-inflammatory aspects of cannabis therapy, and also other effects that are still being researched. If you look down here, CBN is one of the main chemicals that works with CB2. Interesting thing about CBN is actually the product of degraded THC active. So if you let THC stand out and degrade on its own, it will turn into CBN, which is what is responsible and works largely with the immune system in the body. Interesting. Okay, so how does this? What we have in the body is basically you have receptor agonists and you have receptor antagonists. Now, what these are basically chemicals that either bind to a cell's sorry, moving the light around here. It's either a chemical that binds to a cell's receptor or gets in the way from a chemical being able to bind to a receptor. So, let's get that light out of there. Woo, floating orbs, crazy, crazy, crazy gas. Woo! Okay, so here we have antagonists, and like I said, it's a chemical that binds to a cell's receptor and triggers a cell response. Now, if you look down here, let's go down to the bottom here in a minute. So typically, agonists mimic the action of a naturally occurring substance in the body. So say, for example, THC is an agonist. THC is not a chemical that's produced naturally in the body, but there is a chemical that triggers a similar cell response to THC that is naturally produced in the body, and that chemical is called anandamide, and or it's abbreviated AEA. And so anandamide is an endogenous cannabinoid because it has the same effects as a cannabinoid, and it works in the endocannabinoid system. And the word endogenous means that it is found naturally in the body. So the chemical anandamide was discovered in 1992 in Raphael Mechoulam's laboratory by a couple of scientists, and basically anandamide is degraded by the fatty acid amide hydrolase. I'm not exactly sure how to say that, or in short, FAAH enzyme. So when there's anandamide floating around in your body, it's degraded by this enzyme that's in the body. So basically, inhibitors of this enzyme are being, or they lead to an elevated level of anandamide in the body, and when there's an elevated level of anandamide in the body, basically it has certain cell reactions that are found to be beneficial for therapeutic reasons. So let's see if you look at it mimics anandamide. So I've got a cool little diagram here at the bottom. I'm not too much of an artist, so I'm sorry, but this is kind of what you get. So basically, I have down here a nice little picture of a CB1 receptor, and you have this little chemical THC. Now, this isn't exactly what the chemical looks like, obviously, but this is just kind of give kind of a picture to what it is. So we have THC floating along down the body, you know, da 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 da, and it says, hey, I see this thing. It looks like I could fit really, really well in there. So it's like clunk, and it sticks in there, and it causes the cell that it binds to react to it in a certain way. Now, you have this other chemical called anandamide, which is very similar to THC, but it's different all the same. You see THC has a nice little square edges, and this has a nice little round thing, but it still has the same teeth, and it can still sink into these CB1 receptors just fine. So it sinks in there, and it triggers the same sort of cell response that THC does. Now, those agonists, right? So what does this word antagonist have to do with this here? So antagonists block the action of agonists, and it keeps the certain chemicals from binding to the receptors. So let's say you have this anandamide floating on down, and it wants to bind to, let's say, this receptor over here, right? Well, it's floating along, but bam, there's this other chemical, this antagonist that we create or put into ourselves that sticks into the cell as same as the anandamide or THC would. But the thing is that it doesn't produce a cell response. It might be sitting and blocking these holes, but it's not actually causing the cell to do anything. So it gets in the way, and it makes this anandamide keep floating along in your body for a little bit longer than it typically would have. So it tries to find other cells that it can help out with. So I think that's going to do it for us tonight. Thank you very, very kindly for tuning in. This has been episode number 5 of the Alex Toast Medical Marijuana Logs. We'll get into a little bit more thoroughly the different chemicals, this THC, CBD, and CBN here probably in the next episode here. So keep your eyes peeled for that. Thanks again, and you guys have a very splendid night.